5.2 special products. So we're going to take a look at two of the very common special products that we look at. Okay, so first we're going to look at squaring binomials. So if we had something that looks like this, a plus b squared, how we would expand that is we would do a plus b and then a plus b again, right? Because we know that when something's raised to the exponent 2, it's multiplied by itself 2 times. Okay, and then what we would do is we would expand this by FOILing. So we get a times a times b times a, b times b. Okay, and this is the important part of this type of pattern, okay? This is called a perfect square trinomial. Okay? When we see this, we have a pattern, okay? We have a squared, we have b squared, and then we have 2ab. Okay? We can see that we add this to itself. Okay? So looking back here, this is the pattern. Square the first term. So the first term is a, and we squared that, so that's good. Okay? Square the last term, which is b, and that's over here, so that's good. And then the middle term here is twice the product of the first and second terms. So in this case, it's 2 times a times b. Okay, a perfect square trinomial, the definition is a trinomial of this form here, or this form here, that is the result of squaring a binomial. Okay, and we're going to see this a lot when we go and factor. Okay, next one. Product of a sum and a difference. So a little bit different here. Instead of this being a plus b, we now have a plus b, a minus b. Let's go ahead and expand this. A times a is a squared. A times b is ab. Sorry, it's a times negative b is negative ab. B times a is ab again, and then b times negative b is negative b squared. So the important part of this pattern is, again, these middle two terms. We now have negative ab and then positive ab. Those cancel out because one's positive 1 and one's negative 1. Okay, and we're left with a squared minus b squared. When we have this, there's a pattern. This is called difference of squares. And the pattern is you take the first term, which is like a in both brackets, and you square it. You take the last term in both brackets, and you square it. And there must be a minus sign in between. Okay? A difference of squares is an expression in the form a squared minus b squared. Something squared minus another thing squared. And we're going to see that a lot as well in factoring. Okay, so let's go ahead and expand and simplify. So the first three here are squaring binomials. That's that first example that we took a look at. Okay, so x plus 3 squared, what we want to do is we want to write it beside each other. Okay, when we go ahead and expand this, we get x squared plus 3x plus 3x plus 9. And that 3x is doubled, so it's actually x squared plus 6x plus 9. Okay, we can do that by normal FOILing, or we could have used a pattern. So let's go ahead and use the pattern. So the first thing squared, which is x squared, the last thing squared, which is 9, and the term in the middle is going to be 2 times x times 3, which gives us 6x, because it's 2 times x times 3 in that middle. Now let's try to do this just by taking a look at the pattern. So this one is k minus 8, k minus 8. Okay? We can go ahead and FOIL, or we can identify that this is a perfect square trinomial. Square the first, square the last, and then it's 2 times k times negative 8. So this is going to be 2 times k times negative 8, which is negative 16k. And that's how we expand that. Okay, the next one. So this one's a little bit more complicated, so I'm actually going to do that middle term all expanded. So again, this is a perfect square trinomial because it's 2y plus 6x squared. Okay, so what we want to do is we want to square the first term. So we're going to go 2y squared. Okay, we want to square that last term, 6x. So let's just put that in brackets, 6x, and then that's squared. And this middle term is going to be 2 times the first term, which is 2y, times the last term, which is 6x. Okay, now let's actually expand. 2y squared, I get 4y squared. 2 times 2 times 6, 2 times 2 is 4, times 6 is 24, yx. And then this is 36x squared. And we can go ahead and put that in order. We can go 36x squared. This middle term I would actually write as 24xy, and then plus 4y squared. Okay, now D. We can see that m plus 5 and m minus 5 kind of look alike, except for their conjugates. One is positive and one is negative. So we can go ahead and expand this if we want. M squared minus 5m plus 5m minus 25. And we'll see that these two middle terms cancel. So we'll get m squared minus 25. Okay. However, if you wanted to do a shortcut, we would notice that these two terms at the beginning is m, are m. So we can just put m squared. Then 5 times 5 is 25, so 25. And this always has to be a negative. So let's do the short form way for E. We notice that 3a and 3a are the same terms. So let's go 9a squared. We just took it and we squared it. If you want to see that, hold on. We would have 3a and we'd square it, which is 9a squared. Okay, we know it's going to be minus, and we see here negative 4b plus 4b. So these are conjugates, so it's going to follow the difference of squares. So we're going to do the 4b squared, which is actually 16b squared, and that's it. Okay, example 2, this is a word problem. So the radius of a circular helicopter landing pad is increased by 3 meters. So the original radius is r, and then the radius that's increased is going to be increased by 3. So when I think of increase, I think of the positive sign, plus. So I'm thinking that the new radius is r plus 3. Okay, so first, find me a simplified expression for the area of the new circle. So area n is going to just be new circle. We're dealing with pi r squared. So the area of the new circle is pi r plus 3 squared, right? Because we're subbing the r plus 3. Okay, because it asks for simplified, we want to expand and collect like terms. So let's do 2 at a time. Let's expand the r plus 3 times r plus 3, which is what r plus 3 squared is, right? It's going to look like this. But I'm going to use the short form, okay? So because they're similar, or they're identical, we're going to do r squared. We're going to do 9 at the end. And that middle term is going to be 2 times r times 3. Okay, which is going to give us r squared plus 6r plus 9. And if we want to expand this this pi into the bracket, pi is just the number 3, so it acts as a coefficient. So it's going to be pi r squared, which is like 3r squared, plus, okay, when we actually have a coefficient like 6, we put the pi in beside it. So 6 pi r plus 9 pi. Okay, and that's part A. Now, B asks us to find the expression for the increase in area. So this is actually just like the difference. Okay, it's a difference from the small area to the large area. So this blue in here, this is what we're trying to find the area of. So let's go B. Area of the increase. What we're going to do is we're going to take the entire area, which is this right here, like the new circle, pi r squared plus 6 pi r plus 9 pi. And we're actually going to subtract the middle. So we can subtract this in here to just get that increase. So the area in the middle was pi r squared, right? The original. So these two pi r squareds cancel out because we have pi r squared and negative pi r squared. So the area of the increase is 6 pi r plus 9 pi. And that's done. Okay, last question. Example 3, a rectangular garden with the length of 15 and the width of 11. So when I think of this, I think 11 and 15 meters, increased by the same amount on both sides. Okay, so the length is increased and the width is increased. And when we talk about the same amount, we talk about a variable, right? With the same amount, let's represent that as x. And let's represent that as x as well. Okay, so now if we think about it, the area of this entire thing is no longer 15. It's going to be 15 plus x. And the width is no longer just going to be 11. It's going to be 11 plus whatever the x is. So 11 plus x. So now let's think. Write an expression to represent the new area. Okay, so I have 15 plus x and times 11 plus x. Because remember, the area is length times width. Okay, so we have, and we want simplified, so we want it expanded. 15 times 11 is 165. 15 times x, 11 times x, and then x times x. So we're just going to collect these middle two terms and rearrange. So let's put the x squared first. And then 11 plus 15 is 26x. Now let's put that 165 at the end. Okay? So let's call this area of the new rectangle. And now it wants us to write an expression for the area of the increase, or like the difference in the area. So now we're only writing an expression for this purple section. So what we're going to do is we're going to take the area of the entire thing, right? The area of the new, which we found to be x squared plus 26x plus 165. And we're going to subtract the area of the old one, which is 11 times 15, right? Because of the length times the width. But 11 times 15 is that 165. So this positive 165 and negative 165 go away. The area of just the increase is x squared plus 26x, and that's done.